When you solve a problem such as 3 plus what number equals 5, you are solving an algebraic equation. And let me show you how you write that. 3 plus a number, 3 plus what number equals 5. We're going to use what's called a variable. A variable is used in place of a number when we don't know what that number is. So to solve this problem, 3 plus n equals 5, we're going to use what's called inverse operations. Well, here we're adding. We're adding 3. So the inverse operation of adding is subtracting. Inverse means the opposite. So we're going to subtract 3. Now, whatever you do on one side of the equation, you have to do on the other. So we're subtracting 3 from each side, and I want to show you why. When we subtract 3 minus 3, we have 0. So now we have 0 plus n equals 2. And this can be rewritten dropping that 0 to n equals 2. Now that you've added a variable, let's look at subtracting. If we have r minus 6 equals 5, and I want to solve for r, well, we can look at this problem and go, what minus 6 equals 5? Or we can jump right to the algebra. So we're going to do the inverse operation. The opposite of subtracting 6 is to add 6. Remember, whatever we do on one side, we have to do on the other. Now, if I have negative 6 plus 6, I'm back to 0, which is where we need to be. We have done what's called isolating the variable. That means making it so the variable is all by itself on one side of the equal sign. And we are left with r equals 5 plus 6 is 11. r equals 11. Now we're going to work on solving equations by multiplying and dividing. 2 times s equals 12. Notice there's no multiplication sign in between here. We don't need one. If there is just a number attached to a letter, then we know to multiply. And this number has a very special name. It's called a coefficient. So 2s means we multiply. 2 times s equals 12. So you can think about it and go, what number times 2 equals 12? You can also solve it algebraically. Here we're multiplying. We need to do the inverse operation, which is the opposite of multiplying is dividing. And we're doing this to isolate the variable. Now what happens when I have 2 divided by 2? It turns into the number 1. 2 over 2 is 1. So 1 times s is just s. So s is going to be all alone. Now remember, whatever we do to one side of the equation, you have to do to the other. If we divided by 2 over here, we have to divide by 2 over here. And we're left with s equals 6. Now let's solve a division problem. Here we have j divided by 5 equals 2. Well, again, we're doing the inverse operation. Instead of dividing by 5, we're going to multiply. You can kind of even think of this as a fraction, because j over 5, or j divided by 5, is like a fraction with a denominator of 5. So if I want to multiply by 5, really I'm just multiplying by 5 over 1. So when we multiply by this, 5 over 5 is just 1. We've isolated that variable. We multiplied by 5 over here, so we need to multiply by 5 on the other side of the equation. Whatever we do to one side, we have to do to the other. And we're left with j is equal to 10. Now notice this little dot. That's not a decimal sign. Sometimes you can represent the multiplication operation by using this dot instead of the traditional x. I use this often when we're dealing with variables because I don't want you to be confused thinking, is this a multiplication sign or is this a variable? So once you begin using algebra and once you start working with variables, especially the variable x, it's important that you start representing multiplication with a symbol like this. Remember, when you're solving for variables, you have to isolate the variable. And you do this by doing the inverse operation. If you're adding to solve the problem, you need to subtract. If you're multiplying to solve the problem, you need to divide. Those are the inverse operations.